Today we're going to deal with redox reactions in basic solution. The good news is it's the same as the acidic solution, we just tack a step on at the end. That does require lying in the middle of the problem, but that's fine, we'll fix it later. From the acidic solutions, you may remember we're going to assign oxidation numbers, split them up, take care of everything that's not hydrogen or oxygen, and that's the step that I always forget. Take care of the oxygens using water, and you got plenty of water floating around in the solution. Then take care of the hydrogens using H+, which is a lie, because in a basic solution we have excess OH-, not excess H+, but we'll fix that later. Fix your charges using electrons, make a match, recombine, and then we're going to add OH-. That is the new step, right? Add OH- to both sides to cancel H+. So something we want to mention here, why H+, we have a basic solution, which means there's excess OH-, not H+. And as we know, H+ and OH- give you H2O. All right, let's take care of business. I've got this first one written out here. I'm not sure how the space is going to budget, but there's our first reaction, and we need to assign oxidation numbers. There's a video specifically for assigning oxidation numbers, so we'll kind of cruise through that. But you're going to notice I follow those steps too, largely because I can't focus ever. Chromium's a 3+, that's no problem. H2O2, we don't have any fluorine, we don't have anything in its elemental state. We're looking for hydrogen. Hydrogen will be a 1+. I have two of them, 2+, and then this has to be 0 because there's no charge right there. So this has to be 2-, and then oxygen's a 1-, which you're not expecting, but that's what it is in peroxides, and that's why we do this system here. Nothing in its elemental state, no fluorines, no hydrogens. We're going to have to trust oxygen is 2-, 8-, right? 2-, we're going to have to get 6+ right here, and that is 6+. H2O, hydrogen 1+, that's 2 pluses, needs to add up to 0, and that's got to be 2 minuses, 2-. So now we've got our oxidation numbers assigned. We'll take a look here at what's changing. Again, my strategy is to just look at something, see where it is on the other side, and see if it's changed. So chromium is a 3+, and on this side it's a 6+. There's an oxidation going on. The oxidation state's increasing. On this side, hydrogen's a 1. Hydrogen's a 1. Nothing changed there. On this side, oxygen's a 1-, and on this side, oxygen's a 2-. And if you're wondering why we don't mess with this one, it's because we're going to take care of the situation where it changed and it's by itself. So there's my 1- going to a 2-, and we've got our two half reactions ready to go. Our first half reaction, and it doesn't matter which one you put first, we've got the chromium 3+, turning into the chromate ion, CrO4 2-. And this is going to be our oxidation half reaction. 3 is turning into 6. Our reduction half reaction is going to be the H2O2 turning into the H2O. We need to balance everything that's not hydrogen or oxygen. The only thing we have that's not hydrogen or oxygen is the chromium. We have one of each, so we're good to go there. We're going to balance the oxygens using water. On this side, you got 4 oxygens, none here, so you're going to need 4 H2O. On this one, you've got 2 oxygens and 1 oxygen, so you're going to need another oxygen, and we can just sneak it in that way by doubling our H2Os. You could have written another H2O there. We're going to lie and add some hydrogen ions. We've got 8 H's here and none here, so we're going to need 8 H+ over there. I have 2 hydrogens here and 4 hydrogens there, so we're going to need 2 extra hydrogens on this side. We need to then balance charges using electrons, and I'll slow down on this step because this tends to be a step where people run into trouble. On this side, no charge right there, 3+ right there, so this side's a 3+. On this side, I've got 1 times 2- and 8 times 1+, which gives us 6 pluses. And we're going to have to fix this by adding electrons. We can drop this by adding 3 electrons. And you may recall in an oxidation problem or an oxidation half reaction, we're expecting to produce electrons. So that's promising. Looking right here, we have two 1 pluses on this side and a 0, so that's 2 pluses. And we just have 2 times 0 over here, and that is 0. To make a match, we're going to have to drop this side by 2 using 2 electrons. And now that 2 plus turns into a 0 to match. Theoretically, right now, we have our 2 half reactions balanced, and now we need to make those electrons match. In redox, something is producing electrons, that's happening right here, and something is using electrons, and that's happening right here, and those numbers need to match. Our common multiple here is going to be 6 electrons, so I'll multiply this one by 2, and I'll multiply this one by 3. And something you've heard me say in previous videos is distribute that right now, because if you don't, you're going to screw it up later. So I'm going to take that 2 and distribute it. That'll give us 8, and 2, and 2, and 16 there, and then the 6 that we were looking for. Down here, 3 is going to give us the 6 electrons that we need. We're going to have 6 H pluses. We're going to have 3 peroxides, and we're going to have 6 waters. At that point, we need to recombine and simplify them. What I do, and again, you don't have to, but like I got to keep track of things visually. That's going to be our reactants. That is going to be our products, and we'll simplify once they're recombined. And this is where like you end up doing a lot of writing. You've got 8 H2O and 2 chromium ions and 6 electrons, 6 H plus, 3 H2O2. And then at this point I count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Theoretically, I got all the things I needed to get there. In this one, we've got 2 chromates, 16 H pluses, our 6 electrons that we needed, and 6 H2O. A quick check. I'll count again. 1, 2, 3, 4 things I'm supposed to have. 1, 2, 3, 4 of them. And it's supposed to be 2, 16, 6, and 6. 2, 16, 6, and 6. Now there's plenty of places where you can catch yourself if you make a mistake, but I think it's helpful to take care of business right now, just in case. Now we have to do this OH step. We said we've got some H pluses in the solution. I guess we should simplify first. We said we've got some H pluses in the solution, and that's a lie because we have excess OH minuses, not H pluses. Let me pause and do some simplifying here. We had 6 waters. That'll cancel out 6 of those waters. Our electrons better cancel out or we screwed up. I've got 6 H pluses and 16 H pluses, so we're going to lose 6 of those and have 10. And it starts to look a little messy, but we're going to carry through here. Now we're going to take care of those H pluses. We have excess OH minus, and it's worth noting, or rather it's critical to note, that when you're adding H pluses and OH minuses, you're going to make water, all right? And I don't know where the best place to put that is, so we'll sneak it in over here. H plus OH minus gives us H2O. And this is just like in math. In math class, you can't just do something to one side, but if you do the same thing to both sides, that's totally okay. Well, I need to get rid of 10 H pluses, and I'm going to do that by adding 10 OH minuses. And that's okay as long as I do the same thing to the other side. And I didn't really leave room here, 10 OH minuses. Okay. And what that means is these H pluses and these OH minuses have reacted to give H2O, 10 of them. And now we need to resimplify. I had 6 H2Os and I have 10 H2Os, and that's going to leave me with 4 H2Os on the right-hand side. So I'm going to cross that out, cross out 6 of those, so we're left with 4 H2Os. And now we can write our answer and put our phases back in and everything else. Our final answer then, we've got 10 hydroxides, because we're in a basic solution, 2 chromium ions, and 3 peroxides, 2 chromates, 4 waters, and theoretically that should be it. Now I've already noticed that I made a mistake, but we would catch it most likely because of a mass balance with our reactants and products table or whatever. Looking right here, we had 10 OH minuses, 2 chromates, and so 2 chromates looks good, 2 chromates, 6 H's, and then 10 H's gives us 16 H's. And a quick note right here, we've got only 8 H's. So where I messed up, we can spot pretty quickly. I had a 6 there, and I had an 8 there, so I didn't have 6. I actually had 2. And so we didn't cancel out 6 of those, we only canceled out 2 of those, and we had 8. And this gives us then 8 H2O. Sorry about the screw up, but the good news is it's a test of our own process. And in this case then, we've got everything set up. On this side we have 10 minuses and 6 pluses, so that's 4 minuses. On this side I have 4 minuses, and that looks pretty promising. And that 8 is part of that. We'll highlight our answer and move on with our lives. I'm going to pause for a moment and get that other one written. We need to assign our oxidation numbers, and we're going to follow those same steps. Look for things in their elemental state. I don't see any. Look for fluorines. I don't see any. Look for hydrogens. I see 4 right there. We don't really need to do this because, oops, I see 1 right there. We don't really need to do this because those are hydroxides, and we know it's going to be a 1 minus, but we'll pretend that's 3 pluses, and we've got 2 minuses, so we need to balance that out. We need this whole thing to be 1 minus, so this is going to have to be 6 minus from our 2 minus. All right. Anyway, the short of it is that's a 3 plus because you got 3 hydroxides over here, 2 minuses, 6 minuses, 1 minus. So that's got to be 5 plus. Our chromate here, 2 minus, 8 minus, 2 minus, 6 plus. And then our chloride's a 1 minus, conveniently. All right, that's our first step. We're going to split up our 2 half reactions. In this case, I guess it's worth noting, look for what you have and see if anything changes. Well, there's our chromium with a 3 plus, and there's our chromium with a 6 plus, kind of like what happened up there. And then down here we've got a chlorine with a 5 plus and a chlorine with a 1 minus, so that must be our change there. Setting it up then, 3 to 6 is an oxidation, and again it doesn't matter which one you put first. We've got the chromium hydroxide, chromium 3 hydroxide, turning into chromate. And for our reduction, we've got the chlorate turning into chloride. And as a mental note in advance, oxidation should be producing electrons, reduction should be using electrons, and we'll see how that pans out. Our next step is to balance everything that's not hydrogen or oxygen. In this case, we have chromium and chlorine, 1 and 1, 1 and 1. That looks good. Now we're going to balance the oxygens using H2O. 4 oxygens there, 3 oxygens there, so we're going to need 1 water over here. On this one, 3 oxygens and none, so we'll need 3 waters over here to take care of that. Our next step is going to be to lie and put some hydrogen ions in there. On this side, I have 3, and 2 is 5. And so I've got my 5H plus there. Down here I've got nothing and 6, so I'm going to need 6 hydrogen ions on this side. We want to take care of our charge using electrons. No charge, no charge. 0, 2 minus, and 5 plus gives us a 3 plus. And we're going to need 3 electrons to balance that out. And if you look right here, I have 1 times 2 minus and 5 times 1 plus. That's where I got the 3 plus. Down here we have 6 pluses and 1 minus, so that must be 5 plus. And on this side, I have 0 and 1 minus, so that is a 1 minus there. To make this work, I'm going to need 6 electrons. And we should take note that the reduction is using electrons and the oxidation is producing electrons. That is some level of reassurance. We need to make the electrons match, Annoyingly enough, we do have to do that here. We're going to multiply by 2 in this case to get us 6 electrons and distribute that right away. We've got our 6 electrons now. We need to recombine. I'm going to make a mental note to myself in advance. Those are my reactants. Those are my products. And we'll see how this goes. I've got this tape here, which is a disaster of sorts. We've got 2 waters and 2 chromium 3 hydroxides. And 6 electrons, 6 hydrogen ions, and that chlorate ion. This should give us 1, 2, 3, 4, 5 things. 1, 2, 3, 4, 5 things. And it should be a 2, a 2, a 6, a 6, and a 1. 2, 2, 6, 6, 1. You can never be too careful. Looking at our other side, we've got 2 chromates, 10 hydrogen ions, 6 electrons, a chlorine, and 3 waters. And again, a quick count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 things. 2, 10, 6, 1, 3. 2, 10, 6, 1, 3. All right, that looks promising. We need to do some simplifying at this point, if we can. And you don't really have to. You'll notice like there was a bunch of waters that we canceled and added and everything else. And that's how I managed to screw the previous problem up. I feel like if we can get as much out of the way as possible, that's promising. So what we're going to start with on this side, excuse me, is to take care of the electrons first. And if they don't match, you screwed up, go back and fix it. I've got 2 waters and 3 waters, so I can get rid of those waters, and I can get rid of those waters so that I have 1 left. We have 6 hydrogens and 10 hydrogens, so I can take care of that, so that I have 4 hydrogen ions left. And now we can take care of our hydroxide step. And in this particular case, we need to make 4 hydrogen ions go away, so I'm going to add 4 hydroxide ions. And then on this side, I have to do the same thing, so I'm going to have 4 hydroxide ions, right? It's just like math or anything else. If I subtracted 4 hydroxides from this side, I could subtract 4 hydroxides from this side and they'd go away. In this case, I added 4 and I added 4, and that's okay. Now what this is going to turn into is 8 waters, and then we're going to have to do a little adjustment right there. Alright, my brain is obviously not functioning here because this is 4 and 4 gives us 4 waters. I've got another water right there, so I'm just going to turn that into 5 waters. If there's anything else we can simplify, we would do that. There's nothing else to simplify, so let's write our final answer here. We've got 10 hydroxide ions. Those are aqueous. And I looked at that 10. Wow. It is a day, folks. I've got 4 hydroxide ions and 2 chromium 3 hydroxides. And ClO3 minus should give us 2 chromates, 5 waters, and a chloride ion. And we'll just glance right here. I should have 1, 2, 3 things on that side. 1, 2, 3. And on this side, I should have 1, 2, 3 things. 1, 2, 3. A quick check of charge. I got 4 minuses and 1 is 5 minuses. I've got 4 minuses and 1 is 5 minuses. So at least redox is something where no matter how asleep I am, we can always check it and make sure things worked out. In this particular case, we checked it and things worked out. That's pretty reassuring. I'm hesitant to highlight over this tape, but we've got that. All right, I'm going to set up the next one. These are done. Let's hope things can go a little smoother from here out, and this morning can be done. All right, next round, we're going to follow our steps, which I moved over here, and we need to assign some oxidation numbers. Looking right here, I'm not going to mess around like I did last time. Hydroxide's a 1 minus. We got 2 of them, so 2 minus, so that nickel has to be a 2 plus. Right here, we're going to trust those hydrogens, 1 plus, 4 plus, got to add up to 0, 4 minus, so that has to be a 2 minus on the nitrogen. Ni elemental state 0, nitrogen elemental state 0. So now we need to do some quick checking and see what is taking place. Nickel's going from a 2 to a 0. That's a reduction. Nitrogen's going from a 2 minus to a 0, and that is an oxidation. So we have reduction and oxidation. Let's get those half reactions written. My reduction half reaction is the nickel hydroxide turning into nickel. That is our reduction. My oxidation half reaction is the N2H4 turning into our nitrogen gas. I hope you can hear my dog snoring behind me. All right, we need to balance everything that's not hydrogen or oxygen. We have nickel, and it's 1 nickel. We have nitrogen, and we have 2 nitrogens, so that's done. We're going to bust out the water. I have 2 oxygens I need to deal with, so there's 2 H2Os. On this one I have no oxygens to deal with, so that step is done. Now we're going to lie and balance our hydrogens using H+. Again, we don't have excess H+, we have excess OH-, but we're going to fix that at the end, so we don't have to learn a totally separate series of steps. In this case I have 2 hydrogens, and in this case I have 4 hydrogens, so I'm going to need 2 hydrogen ions to solve that. And again, 4 hydrogens, I'll need 4 hydrogen ions to make that work, and we'll keep going from there. I need to balance charge using electrons. I've got 2 pluses and 1 minus. So there's 2 plus on that side. And I've got 0 and 0. So there's a 0 on that side. And my reduction should use electrons. So it's reassuring that I have 2 electrons that I'm going to add on that side. Down here I've got 0 for my charge and 4 pluses. So we're going to need 4 electrons to make that work. Once we have our electrons, we need to make the electrons match 2 and 4, so I can fix this right now by doubling it and immediately distributing so that I don't screw that up later. Alright, and now we can recombine. And as I mentioned previously, I prefer to make a mental note what my reactants are and what my products are. So we're going to rewrite all that. I'm going to try and budget my space so that I have room for hydroxides this time. And we've got 4 electrons to start with. And 4 H+, 2 nickel, 2 hydroxides, and N2H4. On 1, 2, 3, 4 things, 1, 2, 3, 4, 4, 4, 2, 1, 4, 4, 2, 1. So that looks reassuring. On the product side, we've got 2 nickels and 4 waters and a nitrogen, 4 hydrogen ions, and 4 electrons. At this step, we're supposed to simplify if possible. If your electrons don't cancel, you screwed up. So in this case, the electrons did cancel. That's a good sign. Doesn't mean we didn't screw up, but it means we didn't screw up that step. I've got 4 H pluses and 4 H pluses, which means something special has happened, and then I have that stuff, which I can't simplify. Now, we should be adding hydroxides to both sides to cancel any H pluses. You'll notice I don't have any H pluses. So this is my answer. I don't have to cancel any H pluses. And that happens sometimes, and it's kind of convenient. I'm going to throw my phases in here. This is aqueous, solid, liquid, and gas. So I'm going to cheat to save some space, although I don't think it's going to be enough. Oops, boy, poor nitrogen. A quick glance to make sure we balance charge at the very least. No charge on that side, no charge on that side. That looks pretty promising. All right, I'll set up the next problem. Welcome back. I've abandoned hope that I can get my 5th example on here, so I'll just throw a piece of paper over this or something. We need to assign some oxidation numbers. This one looks a little sketchy. because you have three things, so we're going to follow our rules as we know them. No items in their elemental state. Actually, over there we can take care of that one. No fluorines, no hydrogens, so we're going to trust oxygen as a 2-. And now we'll have to deal with this. We know it needs to add up to 1-. This is a 2- there. Carbon versus nitrogen, we're going to expect nitrogen to be a 3-. And so as we set this up, that carbon has to be a 5+. Sorry, 4+ to get my 1-. OCl-, the hypochlorite polyatomic ion, oxygen's a 2-, so chlorine has to be a 1+ to get us there, and you're not really expecting that. Carbonate, 2-. We end up with 6 minuses, 2+. To make that work, we need 4+ right there. Looking at nitrogen, elemental state, and chlorine is an ion, and it's already got that oxidation number. We're going to see what changes. Oxygen stays a 2- all the way across. Carbon goes from a 4+ to a 4+, which is kind of a surprise. Nitrogen goes from a 3- to a 0, so that is changing. Oxygen's 2- doesn't change. Chlorine's a 1+ to a 1-, and that is changing. This is kind of a nice problem because it requires a small amount of extra thought, not a ton. We're looking from a 3- to a 0, so that must be our oxidation half reaction. OCN-, turning into, well, we know we've got that nitrogen, but there's no carbon on the other side, and we're going to get that carbon from the carbonate. All right? So once again, OCN-, we've got this C on the other side that didn't seem to come from anywhere. The only place it could have come from is from our OCN-, so we're going to have to include that right there. I don't think that's super obvious, so it's something to watch for. Our reduction half reaction has got to be the 1+ going to a 1-. We've got the OCl- turning into Cl-. And we're expecting in advance, when the time comes, oxidation should produce electrons, reduction should use electrons. It comes up very often as a question, what happens if you have two reductions or two oxidations, or one of them's not an oxidation or a reduction? Chances are, if you've got at least one reduction or at least one oxidation, it's redox. You have to have at least one oxidation and at least one reduction. You screwed up, all right? So go back and fix it. Our rules, we need to look for anything in its elemental state. We need to balance everything that's not hydrogen or oxygen. In this case, I've got 1 carbon and 1 carbon, but I have 2 nitrogens. So we're going to put that 2 in there, which screws up our carbons. So then we need a 2 right there. Oxygen, chlorine, chlorines match. We can move on with our lives. To balancing oxygens using water. On this side, I have 6 oxygens. On this side, I have 2 oxygens. So I'm going to need 4 waters to fix that. On this side, 1 oxygen. On this side, none. I'll need 1 water to make that work. We're going to lie and put some hydrogen ions in there. I've got 8 on this side, so I'm going to need 8 on this side. I've got 2 on this side, so I'm going to need 2 on this side. Now we're going to fix our charge using electrons. This doesn't have a charge. This has a 1-, and I have 2 of them. So that's 2 minuses. On this side, I have 2 of these 2 minuses, so that's 4 minuses. And I have 8 pluses, which leaves me with 4 pluses. And so it looks like I'm going to need 6 electrons to make this work. And we are producing electrons in our oxidation, so that's reassuring. On this side right here, I've got 2 pluses and 1-. That leaves me with a 1+. On this side, I just have a 1- and a 0. To fix that, we're going to need to use 2 electrons. And that's kind of reassuring because in the reduction, we should be using electrons. We need to make the electrons match, and in this case there's 6, and in this case there's 2, so if we just triple this side, the electrons will match. And so we have 6, 6, 3, 3, 3 for those. We're going to recombine, and again, I find it useful to put a box around what I'm going to recombine. And I know I'm going to have 1, 2, 3, 4, 5 things on this side. That's our waters and our 2 OCN minus, 6 electrons, 6 hydrogen ions, and 3 hypochlorite ions. Oops. On the other side, we have our nitrogen and 2 carbonates, 8H plus, 6 electrons, 3 chloride ions, 2 turtle doves, whatever. All right, glad I had as much room as I did because boy is that a lot of writing. We should have 42663, 42663, and on the other side we should have 128633, 128633. Whew. All right, let's start making things go away. I have on this side 3 waters and on this side 4 waters, so it looks like I can make one of those go away, or sorry, 3 of those go away, leaving me with 1 water. Our electrons better go away, or we screwed up, and they do. 6 H pluses and 8 H pluses leaves me with 2 H pluses. And then it doesn't look like there's anything else to simplify. What I want to do now is take care of those hydroxide ions, because we're in a basic solution. I have 2 H pluses here, so what I need to do is add 2 hydroxides to each side. This will give me 2 waters. And do I have any other waters to deal with? Yeah, I've got that water right there. And so we're going to have 1 water left over. All right, and that is what we have. Let's rewrite it and be done with this one. Right here we've got 2 hydroxides, two OCN minus, and 3 hypochlorites. On the other side we have that nitrogen gas, 2 carbonate ions, 1 water, and 3 chloride ions. I'm just going to do a quick charge check. 2 minus, 3, 4 minus, 5, 6, 7 minus. 2 times 2 is 4 minuses, 5, 6, 7 minuses. So it looks like we have probably done that one correctly. You can do your mass balance as well, which would be wise. But as long as you didn't screw your waters up, your charge balance will be good enough. I'm going to get the last one set up and we can be done with this. All right, it required no cleverness whatsoever to slap a piece of paper down over all the other stuff for the last example. I take some sick pleasure into limiting myself to 1 piece of paper set up per video. It would have been nice to split this into 2 videos, but I'm pretty fed up with Redox at this point, so we're just going to finish this out. You may recall our steps: assign some oxidation numbers. I'm going to look for anything in its elemental state first. No luck. Carbon and nitrogen, I'll trust the nitrogen first. That gives us 3 minus. This has to add up to 1 minus, and that means our carbon was a 2 plus. All right. MnO4 minus, permanganate polyatomic ion, should add up to 1 minus, which means that manganese is a 7 plus. CnO minus, we're going to have to start by, and in fact, if you look at that previous one, we had OCN minus written slightly differently. Same thing though. 2 minus, 2 minus has to add up to 1 minus. And that means we're going to trust the nitrogen here as a 3 minus. We've got 3 minus. And then that has our carbon as a 4 plus. And if I hadn't covered it up, we could probably see that over there. The oxygen's a 2 minus. 4 minus needs to add up to 0. So we've got 4 plus right there. And we do have an oxidation and a reduction. If you look, the carbon's going from a 2 to a 4. And our manganese is going from a 7 to a 4. So we have our oxidation and reduction reactions all set. Our oxidation is the carbon. So we've got Cn minus going to CnO minus. All right. For our reduction half reaction, we have the permanganate, MnO4 minus, turning into MnO2. Looks good. Following our steps, we need to balance everything that's not hydrogen or oxygen. 1 carbon, 1 carbon, 1 nitrogen, 1 nitrogen, 1 manganese, 1 manganese. That's a good sign. We're going to balance our oxygens using water. I'm going to need 1 water over here. And down here there's 4 and 2, so I'll need another 2 H2Os in order to make that work. We need to lie and throw some hydrogen ions in there. I've got 2 on this side, so I'll need 2 on this side. And I've got 4 on this side, and so I'm going to need 4 on that side. We're supposed to balance charge using electrons. In this case, I've got a 0 and a 1 minus, so this side is a 1 minus. And on this side, I've got a 1 minus and 2 pluses, which is a 1 plus. To fix this, we're going to need to have 2 electrons. It's reassuring that our oxidation is producing electrons. Down here, I've got 4 pluses and 1 minus, so that should be 3 plus, and 0 and 0 means we're going to need 3 electrons to make this work. Unsurprisingly and annoyingly, we need to make our electrons match by throwing in some coefficients here. Our multiple of interest is going to be 6 electrons, and so we're going to need to multiply this by 3 and this by 2. We'll do that distribution right away. And then down here we have 6, 8, 2, 2, and 4. It's that time where we need to recombine things and simplify. And I tried to budget a bunch of space because this is a bunch of writing. I'm going to leave room in case I need to add a hydroxide over here, but I should have 3 waters and 3 cyanides and 6 electrons, 8 hydrogen ions, 2 permanganates, and I'll double check 33682, 33682. I got all those. 3 CNO minus, 6H plus, 6 electrons, 2 MnO2, and 4 H2O. Alright, should be 36624, 36624. Alright, that's reassuring. We need to simplify if possible, and water. I'll have 1 left over here. Hydrogen ions, I've got 8 there and 6 there. So I will have 2 of those left. And our electrons sure better cancel out or something went drastically wrong. Now, we lied by putting those hydrogen ions in, so we need to unlie by putting some hydroxide ions. And we're going to have to do the same thing to both sides, so I'm going to add 2 hydroxide ions, which will give me 2 waters, and I need to add 2 hydroxide ions over there. As you note right here, I've got 2 waters there and 1 water there, which is going to leave me with 1 water, and then with any luck we can rewrite our final answer and be done. We've got 3 cyanide ions and water, 2 permanganate ions, 3 CNO, 2 manganese dioxide, and 2 hydroxide ions. Let's do a quick double check here on charge. At least 3 minuses, 4, 5 minuses, 3 minuses, 4, 5 minuses. So as long as we didn't screw our waters up, that looks pretty good. Alright, redox and base. Same steps as acid, throw some hydroxide on the end. Because in a basic solution you don't have excess H+, you got excess OH-. But as you recall from the acid-base videos, you always have both.